In this video I'm going to do classwork 3.4, and I'm going to do numbers 4 and number 19 because they both sort of deal with the same image, okay? So number 4 says, so we've got this diving board, right? And it says, how far out on the diving board would a 60-kilogram person have to be to exert a torque of 1,000 newton meters on the board relative to the left support post, okay? So again, I'm just going to redraw. It always helps me to redraw pictures. So here I've got the 2 support posts, and here is my diving board. So this is going to be my pivot point, okay? And if someone is standing over here, there's going to be an upward moment, right, of 1,000 newton meters, okay, which means there will be a force downward of 1,000 newton meters because it's not moving anywhere. So 1,000 here, okay, newton meters. And remember that this is the, oops, it should be a capital N and a little n, meters per newton, and this is 1 meter, okay? And then over here somewhere, I'm going to have a person that weighs 60 kilograms, okay? So they're actually going to have a force equivalent to 600 newtons, and I want to know what their distance should be, okay? So really what I have here is I have that FD is going to equal FD. We're going to be in equilibrium here. So this FD is 1,000 newton meters. And then over here we have a force of 600 newtons, and then at some distance d, which is the question, right? So if I just take 1,000 and divide it by 600, I get 1.67. So d equals 1.67 meters. That's where we'll create a torque of 1,000 newton meters. Okay? Now it says we're going to use the same diving board, okay? And we have a 60-kilogram person that is going to be standing on the very edge. So let me just redraw. This is for number 19, okay? So we have the board here, and here's a person standing, and they are 60 kilograms, right? And it's asking us what is the force that is exerted on the 2 different posts, okay? Ignore the weight of the board, all right? So really what we want to think about is, first, let's set our pivot point here. If we set our pivot point there, okay, what it does is it says that the force times the distance over here has to be equal to the force times the distance over here. Remember, this is 1 meter and this is 3 meters, okay? So the force downward right here is going to be, so I'm going to have F1D is equal to F2D. Okay? So in this case, my force 1 is what I'm trying to find. 1 meter is my distance away from the pivot point. And then over here I've got force 2, which is going to be 600 newtons, okay, at a distance of 3 meters. Okay? So hopefully you can see here that force 1 would have to be 1,800 newtons. Okay? Now, for the next example, it says, or the next part, it asks us, well, what is the force then preventing the spin? So this thing preventing the spin. So we've got this force, but now we've got this force as well. Okay? And for this one, our point of rotation now is going to be over here. Okay? As if this thing were wanting to smash down through that board. What amount of torque does this thing have to support? Okay, what is its force? So in this case, now, I'm going to have that force 2 times the distance it is away from the pivot point, which is 1 meter again, making our math really easy, is equal to this guy's force away from its pivot point. So that's 600, and now it is 4 meters away from that pivot point. So in this case, the force 2 is going to be equivalent to 2,400 newtons.